Hi, my name is Don Bagwell from the IBM Advanced Technical Skills Organization, and this is the second in a series of video demonstrations of WebSphere Application Server for zOS. In this video demonstration, we're going to explore more on the subject of multiple servant regions. As a reminder, this is what our runtime environment looks like. It's a simple network deployment configuration with an application server configured with two servant regions. And in the application server, we have the Super Snoop application deployed. And here are the topics that we'll cover in this video. The first is a demonstration of how a failed servant region will be restarted automatically. The second topic will be a demonstration of session replication between servants behind a controller in an application server. The third topic is a demonstration of the dynamic expansion of servants if configured to do that. And the fourth is a demonstration of the zOS modify command that allows you to manually expand the number of servants dynamically. WAS on zOS has a facility that strives to protect the minimum number of configured servants. So in the event that we have two servants, as we do in our environment, and one of the servants were to go out, that loss is detected and WLM will automatically restart a servant to get back to the minimum number of configured servants. Here is the SDSF status screen showing our address spaces and the two servant regions, and I am going to simulate a loss of a servant by issuing a zOS cancel against one of the servant regions. Now I've got the ACID ID on the cancel command because we have two servant regions with the same job name, and so therefore I'm uniquely identifying one of the servants. When I issue the cancel command, what we're going to see is that the servant is going to go dark because it's going down, and then we'll very quickly see another servant come in to replace it. I'll be hitting the enter key on the 3270 screen periodically to refresh what you see. Here goes. Here is the SDSF log screen showing the activity on the system during that cancel and restart activity. And if we take a look at the timestamps, we see the cancel was issued at 1683. The start command was issued at 1685, which is 2/100ths of a second later. And the status symbol showing initialization complete for the restarted servant is at 2823, which is a little under 12 seconds later. And the important thing to remember is we had two servants to start with, and so the surviving servant was still up and running and taking work while the failed servant was being restarted. So we did not suffer an outage of application JVMs. We still had one remaining. That's the inner cluster working when we have multiple servants behind a controller. When discussing multiple servants behind a control region as a form of inner cluster, the question naturally comes up whether or not session objects can be replicated between the JVMs, and the answer is yes, and the mechanism used to do that is the same for regular WebSphere clusters, and that is to define a replication domain and include the server, and when that's done, then all the servants for that server are included in the replication domain. So in the event that a set of session objects is created in a servant region, what WAS on zOS does is it will keep a copy of those session objects in what's called the data space that's owned by the control region. And in the event that we need to copy the session objects to the other JVM, that is performed with a cross-memory copy into the surviving servant region. We do not need to push those session objects across the network when we are replicating between servants on zOS. Here is the administrative console for WAS, and if we go under Environment Replication Domains, we see that we have a replication domain created with a name that's equal to our server. And if we click on that replication domain and see what members are part of that replication domain, we see that our server is in fact a member of this. And if we go to the properties of the server itself and click on Session Management and then Distributed Environment Settings, we see that this is configured for memory-to-memory replication, JVM to JVM, and if we click on that link, we see that the replication domain that this server is a member of is in fact the one that we showed earlier. Here is the SDSF DA panel again, showing our address spaces. There are the two servants, and there are the STC numbers for each of our servants. We'll need this when we invoke Super Snoop so we can know which servant we go into, and when we kill that servant, we'll be able to see that we'll go to the other servant, but our session will still exist because it will have been replicated over. Here is the first invocation of Super Snoop, and this is showing us that we landed in STC 00120, which was one of the servants. I'll refresh this a couple of times to show you that it keeps going back to the same STC. And now we'll kill that servant region and we'll refresh this, and what we'll see is that the page count will continue up, not be reset, continue up, but will land in a different servant region. So the servant has been killed. We're back at Super Snoop. Let's refresh the screen and see what happens. And there we go. The page count went to 4, but the STC number has now changed to STC 00111, which was the other servant region. Now that means that our client session has been replaced to the surviving servant, and the session object has been replicated over. WAS on zOS provides the ability to dynamically expand the number of servants based on workload presented to the server if the maximum number of instances defined is greater than the minimum and the maximum has not yet been reached. Now to demonstrate this, we're going to use a software driver tool called JMeter to run a bunch of user requests into the server, and in so doing we're going to see a third servant come up. Now it's not instantaneous. It takes a little bit of time because WLM is monitoring the entire environment and it doesn't want to start an additional servant if it doesn't really have to. But once it determines that it's a good thing to do, it will start it up. Here is the server instance definition showing a minimum of 2 and a maximum of 3. That allows us room for expansion. Here is a telnet session with the 3270 screen in the background. I'm going to invoke JMeter from the telnet, and then I'm going to switch over to the 3270, hit the enter key periodically, and we should see that third servant come up. So here goes. All right, JMeter is started, and now we're in 3270. And there is the third servant. Generally speaking, we don't see many customers taking advantage of the dynamic expansion capabilities. What they usually do is they define some number of servants based on an expectation of workload, and if they need more servants, they use the zOS modify command to get that number of servants active. And how this works is like this. If the checkbox for multiple instances enabled is checked, then the zOS modify command can be used to dynamically change the runtime values for min and max. And so I'm showing you an example here of modify the server job name, WLM underscore min underscore max equal 33. Now that's going to increase the minimum number of servants, and if the minimum value is greater than the current number of servants, then more servants are going to be started. And I'm going to show you that next. Here is our SDSF display active panel one more time, showing our server with 2 servant regions. This is based on a configured value of min 2, max 2. And what we're going to do is issue the modify command to change the runtime min and max to 3,3. And what we will see is that the additional servant will get started almost immediately. And there is the additional servant. And that's the end of this video demonstration on multiple servants with WebSphere zOS. In this demonstration, we looked at the restart of failed servants. We looked at session replication between servants. We took a look at dynamic expansion of servants and the use of modify to expand the number of servants. There's more on WASZOS in the other demonstration videos.